Alright, so let's continue with time series. So in the last video, we talked about the four components of the time series, right? The trend component, the seasonal component, the cyclical component, irregular component, right? So next we'll talk about the modeling a time series. So here, this is our goal of our analysis, right? So given you a time series, how you can model a time series so that you can make the forecasting or make the prediction for the future, right? So here we will have generally we have two classes of the methods. The first method class is the smoothing method. Right, so smoothing method is a kind of a method that let's say this way. If I have a time series like that. Alright, so in the end, for time series, I kind of can connect every point with lines, right? Something like that. In the end, for smoothing method, we want to smooth out the irregular component so that the underlying patterns will be easier to see. So what does that mean? That means so for example, this is my raw time series, right? But actually, based on the raw time series, it is hard for us to find the pattern, stable pattern, right? Based on these random fluctuations, right? So what we do is, based on the smoothing method, after smoothing the time series, you may find some smoothed line. That means after you smooth the lines without removing these random fluctuations, for example, after my sample is about 2019, in the end, based on this direction, I kind of know what happened to 2020, right? So I don't know the much away future, but I can at least I know something about what happened about 2020, right? So based on the trend, I make the prediction. This is the smoothing method, right? So for the smoothing method, it has the advantage and disadvantages, right? So advantage is you don't need to assume there need to be a trend or seasonal components for the time series. For any time series, even for the time series doesn't have the trend and doesn't have the seasonal component, you can still smooth the trend, smooth the time series to make the forecasting, to make the prediction. Right, so this is the advantage. You don't need to have the assumed condition. But the disadvantage is you can only forecast the near future, which is only make the prediction or the forecasting about one time period, right? So if your period is about 1 year, it's recorded every year, then you can only make the next year, only make the prediction for next year. If your data, your y response variable values are recorded for every minute, then you can only make the prediction the next minute. All right, so this is the first disadvantage for the smoothing method, and another disadvantage is just based on this sample, based on this time series, you just make the prediction for the time period, but you don't have any model for other points, right? So you don't have any model. You just based on the previous ones, I just get the value for the next one. All right, and also the most important is it is very sensitive to outliers. So for example, if I have another point, it's like here, right? So if I have an outlier here, that means when I connect the points for this point, it will going up, right? So when I connect to the outlier here, it will be going up. Then based on this trend, the next point will be going up, something like that, right? So for the smoothing method, it is the most important two disadvantage is the first thing, it is only limited to one time period, and also it is very sensitive to the outliers. All right, okay, so this is about the smoothing method, and then we have another class of modeling a time series or make the prediction about the future. We call it is regression based modeling method, right? So this method will be very close to whatever we learned before exam 2. So we still need to use the linear regression or multiple regression to model this time series, but this is not regression method. The smoothing method is just based on the calculation of based on all these previous data, right? But this is based on the regression method, which is about modeling, right? So actually this method is our real modeling method. All right, of course, for regression-based modeling methods, we also has its advantage and also disadvantages. Right. So first advantage is you can get the model thing, right? You can get the model behavior, and once you have the model, it is good for any kind of this time series, right? So, and if a time series has a trend component or both trend and seasonal component, then we will prefer to use the regression modeling method because it is more stable. All right, okay, so but if a time series doesn't have a trend component and also doesn't have the seasonal component, then you need to use the smoothing method, right? Because smoothing method doesn't require for any trend component or seasonal component. But for the regression-based modeling method, you need at least one trend component. And also if you have a seasonal component, then you can also model the seasonal component, but at least you need to have the trend component. Right, the advantage, this is the disadvantage, right? So advantage is you can forecast a further future, right? So you can use the model to make the prediction for more than one period. But here you still need to be very careful about the extrapolation. So say if the height, remember that if the height is recorded for a boy, right, from 2 years old to 18 years old, right, based on this time series, something like that, so it will keep growing like that. You can make the based on this time series, you can make the prediction maybe the near future, maybe 19 years old, even 20 years old, maybe the prediction is still accurate. But can you make the prediction? Can you make the forecasting about what is his height at 50 years old again? No, still no. Alright, so still has the extrapolation problem. You can only make the forecasting or the prediction for a little bit longer than the smoothing method. So for smoothing method, you can only make one prediction for one time period, but for the regression method, you can make the prediction for more than one time period, but not too far away. Not at 50 years old. You can only make maybe 19 years old or 20 years old. You cannot make the prediction too far away. All right. So we have already talked about smoothing method, regression method, but what are they exactly? Right. So for this video, we'll just focus on the smoothing method. Right. So for smoothing method, here in this class, we only talked about two methods. Right, so this is the first class of the modeling method. This is the second class of the method. Right, so for smoothing methods, there are thousands kinds of the smoothing methods. So here we will only focus on two of them, very classic ones. So the first one will be called the moving average smoothing method. And second one, we'll talk about the exponential average method. All right. So let's talk about the first smoothing method. We have already talked about that, so we'll just skip that. You can read this part by yourself. All right. Okay. So next, let's come to this example. So this example is the plot of a time series for the daily value of DJIA in 2012. All right, so from this time series, is there any repeating pattern for the seasonal effect? I think it is no, right? So there's no stable pattern for each season, and there's also no evidence for the trend component, right? Because overall it is not increasing or decreasing. It is increasing, decreasing, increasing, decreasing. So overall there's no decreasing or increasing thing, right? So for this case, for this kind of time series, we'll use the smoothing method instead of the regression based method. All right, okay, so for here you will see that these points doesn't follow any specific pattern. It has many random fluctuations, right? So they keep jumping like that, keep jumping. If you connect with the lines, then you will see a lot of jumpings within for this overall trend. You keep jumping like that, right? So what our job is to find a smooth line so that follow this. We kind of know that after the September of 2012, what will be the value of y for 2012 in October, all right, in the next time period. All right, okay. So this is our goal. We want to find this line to make the prediction for the next time period. All right, so first we'll introduce the basic, very basic smoothing method. It is called the simple moving average method. All right, so this simple moving average method is the basic, it's the foundation of other many thousands of thousands kind of smoothing methods, right? So this is the first thing you need to learn so that you can understand others. All right, okay, so what is the simple moving average method, right? So sometimes we just short for moving average method. Right, so the moving average replaces each value in the time series by the average of adjacent values. Right, the number of values used to construct each average called the length L of the moving average. A moving average of length L denoted of moving average MA of L simply use the mean of the previous L actual values as the fitted value at each time. Okay, so I know these 3 paragraphs doesn't mean anything to you. It's not very straightforward. So let's just look at the general idea and then we'll go through an example. So this is the calculation I talked about in the first video. You do need some calculations and you do need to know how to make these calculations. Alright, okay, so here in these 3 things, 3 paragraphs, at least you can find that we need to specify the length, which is short for L. Alright, so first for the simple moving average method, we need to specify the L first. So what is L? L is the length of average. Alright, so what does that mean? Let's look through this example. Alright, so this is the DJI time series, which is for this time series. This is the raw data of it. Alright, so this is the DJI value. Alright, and then I want to calculate the MA5. You see that what is MA5? It is just a short for moving average smoothing method with the L equals to 5. Right, so MA5, that means L equals to 5. Alright, so what is L again? It is the length of average. Right, so based on this raw data, what is the MA5? It is, we say L is 5, right? So we have 1, 2, 3, 4 fifths. Alright, and then L is the length of average. Then I'm averaging the first 5 raw data. Alright, so how to get the average? You sum of all of these together, divide by 5. Right, so after you get this, you get this number. Right, 1, 2, 3, 9, 6.82. So what is this? Is this the prediction? No. Alright, so this is, we call it is YT estimate. Right, so this is the estimated value, estimated Y value at time T. Alright, so we don't know what is the time for this point, so we just say this is the estimated value for the Y at the time 5. Alright, so this is the estimated value. Alright, so what is this column? This column is the observed value at time T. Right, okay. Well, we don't look at this term yet. You just look at these 2 columns. Alright, and then we first get the first estimated value at time 5. Alright, then we will move to the next 5. We'll move to the next 5. All right, so the length is 5, right? So we are moving to the next 5 values and then calculate the average of these 5 values. So we sum up of these 5 values and then divide by 5. We get this. So what is this? This is the estimated value at time 6. All right, so that means next one, you can imagine, you can guess, right? So what about the next one? Next one, the average or the estimated value at time 7 will be equals to, from here, from the 3rd to the 7th. Right, so we are moving 5 averages. All right, so we have the first 5, get the average, we move to the next one, get the average, we move to the next 5 to get the average. And then these averages will be called the estimated value at the time t. All right, okay, so that means now we come back to the name of this moving average, the smoothing method's name. It is called simple because we just take the average. We didn't do anything else. We just sum up them together and then divide by the length, right? So it is simple. Moving because we do one by one every 5 and then move to the next one, move to the next one, right? So we say it is moving and then we do the average and then this is the method, right? So the overall name of this method is just a simple moving average method. All right, in short for MA, right? Moving average method. All right, so you can do one by one until the end. In the end, you will have another column, which is the estimated value at time t. Right? So for this column is for L equals to 5. Right? Okay, so what about L equals to 15? That means how you can calculate the moving averages. Now L equals to 15, that means you are averaging every 15 observations, right? So this is 7, number 8, number 9, number 10, number 11, 12, 13, 14, and 15. All right, and then if L equals to 15, what you need to do? You need to average all of these 15 observations. All right, and then sum together, divide by 15, you will get the first value of the average. All right, so first value of the estimated value. So this column is also for the estimated value, but now we change L to 15. So for the 15, you need to sum up all the first 15 of them and then get the average. How to get this value? It will be from 2 to 16. How to get this? It will be the third, from the 3rd to the 17. All right. So you may ask me, what about the previous values here? Are they zeros? No, they are even not zeros. They are just not applicable. NA, 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 NA. For this one will be NA, NA. You do not have any value before the 15th. All right. Okay, so this is to how to get the estimated value. All right, now my question is, I have this plot. So this is again this based on this one, right? So this is still the same DJI time series, but now based on L equals to 5, I have L equals to 5, and I have another L equals to 15, and then I plot these values in the same time series, and then you will have two smoothed line, right? Okay, so my question is, here I have the yellow one, I have the blue one. So which one is for L equals to 5? Which one is for L equals to 15? We say the blue one is actually smoother than the yellow one, right? So we say for the blue line, the smoother one, the L equals to 5 or 15. Think about it. We say what? We say if L equals to 5, we just averaging 5 of them, right? But for L equals to 15, we are averaging every 15 observations. So which one is more closer to the population mean? Which one is closer to the true mean? Of course, will be 15 one, right? So that means if you are getting L equals to 15, you are averaging 15 of them for every point. Then the line will be smoother, which is the blue line. All right, so and the other one will be, of course, will be the yellow one, because we only average 5 of them for each time, right? So it will be more closer to the raw data. All right, so here we have two sentences I want to talk about. The first one, we say the longer moving average is the time series is smoother, right? So that means when L increase, the time series will be more smoother. But at the same time, if it is smoother, we are averaging more data points. That means if there is any change for the next point, it will not very sensitive to it, because we are averaging 15 instead of 5, right? So for each point, it doesn't contribute too much as the contribution of 5, right? So that means when the L is increasing, the time series will be smoother, but it will not be as sensitive as the L is smaller. Right, so we say when L is increasing, the time series will be more smoother, and the sensitivity will be decreased. Right, it will react to the rapid changes in the data more slowly, because it depends on 15 of them, not just one of them. All right, okay, so in the assignment, I gave you this kind of plot, or the scatter plot, or the time series, and then I gave you, for example, the yellow line and the blue line, and I may ask that one of them is L equals to 5, the other one is 15, then which one is 5, which one is 15? You need to know which one is which. All right, okay. And of course, you need to know how to calculate these estimated value. All right, based on the given L. So the L will be given to you, but based on the L, you need to know how to calculate these estimated value of y at time t. All right, but remember that our goal for modeling the time series is to get the prediction or the forecasting for the next time point, right? So here will have this formula. This formula is easy to understand. Is that if you want to make the prediction for the next time point, you need to use the previous estimated value. So for example, if I have, let's say this is the example, right? So if I have the estimated value for 2018, which is, after my calculation, it is 221, right? Then I can use this estimate value to make the prediction for the next year, which is 2019, which is just equals to the estimated value of 2018, which is just a 21. All right, or the other one, or the other way, if I want to make the prediction about 2019, how you can find the predicted value or forecasted value for 2019? We need the estimated value for 2018, and then you need to calculate the estimated value based on averaging the L observations, right? And then, for example, if you still have 21, it will be just 21. So it's just these two formulas are the same. The idea is, if you want to make the prediction of the next time point, you need to use the previous estimated value. And then how you get the estimated value, you need to make the averages. All right, so again, that means the same thing we have already talked about, that we can only use this method to forecast a one time period into the future. All right, okay, so this method, which is the simple moving average forecasting method or average method, it is also called the naive forecast. What does that mean? That means when we calculate the estimated value, we are assuming that for example, L equals to 5, that means every observations in these 5, we are assuming that each observation is having the same contribution for the prediction, because we are taking the averages, right? So we are assuming that every observation contributes the same equally to the prediction or the forecasting. All right, so that's why we call it is naive forecast, because in our real world, it will not be exactly the same contribution for the prediction, right? So actually, most of the cases will be the recent values will contribute more than the previous values, than the historical values, right? So that's why we call it is naive forecasting method. But it is the basic method. We need to learn about that first. All right, okay. So the moving average are often used as the summary of how a summary of a time series is changing, and of course the outliers will change this the prediction a lot, because if you have an outlier here, if you have a very big values for this observation, then your average will change much bigger than that, right? And then if you use this to make the prediction for the next time point, your prediction will be much higher than it should be, right? Okay, so this is the simple moving average forecast. All right, so this is called naive forecast. So next we'll talk about the weighted moving average, which is the improved type of moving average method. Right, so it is also belongs to the smoothing method. The idea is the same. We want to smooth the time series so that we can get the forecasting about the next time point. But this smoothing method will give the weight for the recent value and previous values. So this is the general formula for getting the estimated value, which is the estimate value at time t. All right, so you don't need to remember this formula because this is just a general formula for all kinds of weighted moving average method. But here in this class, we only focus on the easiest one, which is we call it is exponential smoothing method. All right, on the book, it also have the regressive moving average method, but we will not cover in this class. All right, so if you are interested about this part, you can go through the book, and if you have any questions, you can just let me know and make discussion with me. Alright, so in our class, we only focus on the exponential smoothing method. It is a improved smoothing method than the simple moving average method. We still kind of get the average, but we give the different weight for the previous observations. So actually, here, if you look at the formula here, that means for every observation you have a different weight. But for the exponential smoothing method, we just make it simple because we just divide into two parts. So for example, this is the year of 2019. All right, and then I have the previous years. And then I just divide them into two parts. The one part is just for this year, and the other part is all the historical values, all the previous values. I gave the weight for this current value as alpha, and then the other values, all the previous values, will be 1 minus alpha. So that I have two parts, two weights. The two weights, the first weight is for the current value, and then the other parts will be all the previous values. All right, so I just write here, we assign the weights. All right, so we assign the weights. The alpha is the weight for current value. All right, and then the rest of the weights, which is 1 minus alpha, will be the weight for all previous values. Alright, so let's look at the details. So this is the idea of exponential smoothing method. Alright, so let's look at the details. Alright, so the exponential smoothing is a weighted moving average with the weights that declined exponentially into the past. Alright, so this is the definition for exponential smoothing, but we just use the reduced formula, right? So there's no exponential thing. The original formula will be like that, and then after some calculation, some summary about this, this formula just changed to this. Alright, so this is the way how you calculate the estimated value at time t. Right, so let's look at this formula. What does that mean? That means the estimated value for y at time t equals to the weight times the weight of the current value times current value plus the weight of all previous values times the estimated value for the previous one. Right, so it's the same thing. We have the weight, we have the value, we have the weight, we have the corresponding value. All right, okay, so let's get some general idea. We say when the alpha equals to 0.5, then what does that mean? We say alpha is the weight for the current value, right? So if alpha equals to 0.5, that means 50% of the weight is based on the current value. The other 50% of the weight will be based on the previous value. That means the current value and the previous values have the same weight. They have the same contribution to the prediction. All right, so next, what if alpha is close to 1? That means alpha is closer to 1. That means alpha is the weight for the current value, right? If alpha is closer to 1, that means current value is very, very important. Then that means 1 minus alpha will be very close to 0. That means all previous values are not that important. So for this case, if alpha is closer to 1, that means the current value is very important, but all previous values are not that important. Then that means producing forecasts that react rapidly to volatile events. Right, so what does that mean? If you have a rapid change at some point, then if alpha is closer to 1, that means your prediction will be very sensitive to this rapid change. Right? So that means the sensitivity is very high if alpha is closer to 1. All right, the other way, if alpha is close to 0, what does that mean? We say alpha is the weight for current value. Alpha is closer to 0, that means current value is not very important. All the previous values, the historical values, are very, very important for the prediction, right? So that means previous values will be a lot of values, right? Current value just 1. That means the previous values have more contribution than the current value. That means it will producing the forecasts that are stable and smoother because our sensitivity will be decreased because it would depend on all previous values. So if your current value changed, there is a rapid change for the current value, it doesn't change your prediction a lot because it is not very important for prediction, right? Then your sensitivity will be decreased. But at the same time, the same idea in the simple moving average method, if the sensitivity decreased, that means your line will be smoother. All right, so we say if alpha is closer to 1, then it will be very sensitive to the rapid change, but it will not smooth. But if alpha is closer to 0, that means the current value is not current value is not very important. The previous values are important. Then it will be not very sensitive to the big change, the rapid change of the current value, right? So it will be not that sensitive, but the line will be smoother. All right, okay, so here I have an example. We say if alpha is 0.75, then the historical data, that means all previous values, are weighted only 25%, right? And the current value has more weight at 75% because alpha is the weight for the current value. All right, so I do not want to explain this. I don't want to confuse you. This is the original formula for exponential moving average method, just based on the observed values. All right, but after some calculations, the formula is just simplified to this formula. This formula will based on the observed value and the previous estimated value, not observed value anymore. All right, okay. So we only use this formula. Do not use this formula, right? So it's not important. Do not use this. I don't want to confuse you. Right, don't use this. All right, so let's get some general idea again, right? So this is the same time series, all right? And then based on alpha equals to 0.75, alpha and another alpha is 0.1. Based on 0.75, I can draw a smooth line, right? And based on alpha equals to 0.1, I can also get the smooth line. Now you need to decide with these two lines which one is for alpha equals to 0.75, which one is for alpha 0.1. We say this alpha is close to 1, right? So we say when alpha is closer to 1, that means current value is very important, right? So if the current value is important, that means it will react very rapidly to the changes, right? So that means the line will not be very smooth. So which is it? Will be this purple one, right? It will follow these points very well because it reacts to the changes very quickly. All right, and for this one, alpha equals to 0.1, that means this alpha is closer to 1. This alpha is closer to 0, right? So if alpha equals close to 0, that means the current value is not important. The prediction would be more focused on all the previous values. That means your line will be very smooth, right? So which one it is? The yellow one, right? So here, I don't want you to remember the rules. All right, so I don't think it is a good idea to just remember them. I want you to understand them so that even though you don't remember these rules, you can always figure out which one is which. All right, just to think about, we say alpha is the weight for the current value. All right, and then next will be about summarizing the forecast error, right? So I really want to continue with that, but I cannot make very long videos. It cannot be uploaded. So let's stop here, and then next video we'll just focus on this part, and also we'll work on a simple example. All right, so see you in the next video.